at what's the difference between a physical and chemical change, and hopefully with the Gizmo lab that you're doing right now, you should be able to identify the difference between physical and chemical change. So here is a ice cube that has been sitting on the countertop, and you could argue that it looks like chemical change, but guess what? Um, you're starting with solid water. So if you're starting from solid water to liquid water, that is not a chemical change. So this is just an example of a physical change. So melting ice is not a chemical change. Another example where it's still the same substance, it's just that it's going from a solid to a liquid or a liquid to a gas. The example would be salt dissolving in water. So the way you prove that is if you took a glass of water and you added salt to it, if you let that water sit over time and evaporate, you should end up with salt after the evaporation. So it is a physical change, not a chemical change. Now, another example is something that we don't always get to see very often, but it's essentially dry ice sublimating. So, dry ice is carbon dioxide, and it's solid carbon dioxide. And what happens is it becomes a gas. So, it becomes gaseous. Sorry, I can't spell. So it's still carbon dioxide. It's just that it went from a solid state to a gas state. So that is definitely not a chemical change. So what is a chemical change? Well, hopefully you saw in your gizmo that you did that it has to be where the product is different. So if you took an egg and you put it in a hot pan, you would notice that the yolk and the egg white changed. So there definitely was a change in color as a result of this. And that's one of the signs of a chemical change. Now you have to be careful because the product has to be different. In the previous slide, it was still the same substance, even though it went from maybe a solid to a liquid or a solid to a gas. So you have to be really careful with that. Now, some of the clues for chemical change are the following. So you might see heat forming. Obviously, if you see the logs there, as they are being burned, we see light or heat produced, and the wood goes from wood fiber to ash. So it actually changes into a new substance. Now, if you got the chance to maybe be outside and have a little campfire, you would know that if you have a change in color, if you're roasting a marshmallow, it should go from white to a tan color, and hopefully you didn't burn it, but I know some people like burnt marshmallows. So notice that there's a difference in color when you toast a marshmallow. Now, you could do this in your own house. If you took some baking soda and you added vinegar to it, you would see production of that gas. And it has to be a new gas. So be very careful when you are looking at something like a pot of water. People think that the bubbles are a sign of a reaction, and it's actually just dissolved oxygen, so it's not a new gas. And then the last thing is a precipitate. So if you take two liquids and you combine them and you see a solid forming at the bottom, and that solid is a new solid, that is an example of chemical change.